Guys, broadcasting the solutions to today's lab 1.1. The answer to the first question was vial A, and vial A ended up being the cobalt 2 chloride. The answer is this vial was brightly colored, thus must contain a transition metal cation. Recall that cations are positive from the third energy level. Now silver chloride was a distractor because silver is a transition metal, but silver is in the fourth energy level of the D block, so that does not count. Go down to number 7. It says which vial can be determined based on its solubility in water. This was vial E, which turned out to be AgCl. Okay, this vial contained a compound that did not dissolve. Solubility rules said that Cl minus and Ag plus 1 equaled an insoluble product. Okay, thus silver chloride must have been the insoluble product, as every other chloride compound was soluble. Okay. On this next one, the answer was D, and that was barium chloride. This is a little tricky, and I'm going to write out how we got this solution. What we did is we took the remaining compounds. One was NaCl, one was BaCl2, and the other was NH4Cl. Sodium chloride, barium chloride, and ammonium chloride. And we actually reacted each of them with sodium sulfate. Now initially, every single compound here is aqueous, soluble. So what they did when we mixed them is they swapped their anions and their cations. So what we have to do here is go through and determine which mixture produced a new compound that was insoluble. This mixture produced Na2SO4 and NaCl. Both of those are soluble, so NaCl could not have been it. This one produced NaCl and BaSO4. BaSO4 is insoluble, so BaCl2 is the most reasonable choice. Let's go back and look at the new combinations here. NaCl and NH4 2SO4. BaCl2 is the only obvious choice, so let's cross that off the list. Okay. This next one was pretty simple, and the vial that was NH4Cl was vial B, okay? And that's because the NH4 cation reacted with the OH minus anion. This came from the NaOH, and this came from the NH4Cl, and together they produced ammonia and water. And I told you guys that ammonia stunk really bad, so here is the product that stunk. I apologize about that. I think this was vial B. Okay, so that allows the last compound to be NaCl, and let's go through and do that right now. So we know that vial A was COCl2. We know that vial B was NH4Cl. We know that vial C must have been the NaCl. We know that vial D was BaCl2, and we know that vial E was AgCl. Okay, we asked for the Lewis structure for ammonia here. I know a lot of people didn't get this last year, and we'll go over this in detail in one of the units. Okay, we have the valence electrons. These came from the periodic table. We just simply connect the lonely dots and redraw it in a nice manner. This is actually called trigonal pyramidal. Okay, we're going to provide the molar mass for NH3. So we have N and we have H. There's one N, there's 3 H's. Multiply this by 14, multiply this by 1. We're going to get 14 and 3, which gives us 17 grams per mole. Notice I'm rounding the numbers. That is totally fine. Is ammonia ionic or covalent? It's covalent. Because there is no cation anion combination. You're going to get the cation here either from metals, or you're going to get that cation from ammonia, NH4+. Okay, moving down to the AP question. Below, I see that this is free response number 5. It's a lab question, so it can't be free response number 4, because 4 is always 3 reactions. I'm going to hammer that in your head, guys. Very important free response question. All right, let's go to this actual AP question. You're going to find it extremely easy because it's basically based on the lab. So we know that the answer to this is COCl2. So we got rid of that one, and we know why. It's because it contains a transition metal cation. You guys can write out that answer there. I don't have enough time here in this podcast to do that. We know that AgCl can be identified by adding water because it's insoluble. We did that in the lab. I'm going to come back here to C. In D, we know that BaCl2 can be identified by adding sodium sulfate because it produces that barium sulfate insoluble product. And we know that NH4Cl can be identified by adding NaOH because the NH4 plus and the OH minus are going to produce that stinky NH3. Coming back to C, it asks, what could you add to confirm the identity of the AgCl? Okay, it turns out that if you add ammonia to AgCl, it dissolves it and it produces this weird kind of complex that looks like this. It's got an Ag, and then we're going to have 2 ammonias connected to it, and that thing is going to have a plus charge, and what's also going to happen is that Cl2 is going to get kicked out. Okay, and we're going to end up, no 2 there, end up with a 2 here. So adding ammonia to silver chloride produces this complex ion of silver and ammonia. Notice it's got that positive charge, and that's what allows it to dissolve. I believe that this is going to be 2 Cl minuses here instead of that Cl2. So answer to C, ammonia will dissolve silver chloride. Okay, just a vocab term there. I'm not going to focus on that, but wanted you to get a chance to think that way. Hope this helped, guys. Take care. Have a good night.